By the time German generals learned what had happened, the impossible had already been accomplished. A forest clearing that had been empty just hours before had transformed into a fully functional airstrip, ready to receive fighter planes and bombers. Reports flooded the enemy command posts in disbelief. No one could imagine that such a feat could be achieved overnight. The sudden emergence of the airstrip disrupted their assumptions, challenged their sense of control, and forced them to question the limits of what American ingenuity could accomplish. This was not merely an act of construction. It was a demonstration of vision, precision, and audacity executed under the most extreme conditions. The story of this extraordinary achievement began long before the first steel mat was laid or the first truck rumbled into the clearing. It began with careful planning, relentless preparation, and a belief that engineering could overcome even the most formidable obstacles. The mission assigned to American engineers was unparalleled in its ambition. They were tasked with constructing a runway in enemy-controlled territory, entirely from portable materials in the span of a single night. Success depended not only on speed but on flawless execution. Any miscalculation could result in the collapse of the airstrip under the weight of aircraft, exposure to enemy fire, or catastrophic failure during landing or takeoff. For these engineers, conventional construction methods were insufficient. Innovation, adaptability, and precision were essential. Each member of the team understood that their work was not just technical but strategic, that the airstrip would influence operational decisions, impact supply lines, and alter the balance of power in the region. Preparations began with detailed reconnaissance of the selected site. Aerial photographs, intelligence reports, and ground surveys were combined to assess the terrain's suitability. Engineers measured soil density, mapped drainage paths, and studied the surrounding landscape for potential hazards. Every slope, dip, and obstacle was documented. Even seemingly minor details, such as the placement of rocks or the density of tree cover, could affect aircraft safety. This planning was meticulous. It required the integration of military strategy, engineering expertise, and an understanding of operational psychology. The site had to be efficient, concealed, and capable of withstanding repeated aircraft landings without failure. Innovation played a central role in the operation. Trucks were specially modified to serve multiple functions: leveling soil, transporting materials, and deploying prefabricated steel mats. These mats, lightweight yet sturdy, could interlock to create a stable surface capable of handling the heavy load of aircraft. Teams rehearsed procedures repeatedly, ensuring that each mat could be positioned and secured in seconds. Fuel, tools, and essential equipment were preloaded in a sequence that minimized downtime and maximized efficiency. Each truck and team member became an integral component of a larger system, moving with precision and coordination. Execution demanded seamless coordination under extreme conditions. On the day of the operation, engineers and supporting personnel arrived at the site with measured calm. Every action had been rehearsed, every contingency anticipated. The clearing was transformed into a carefully controlled zone of activity. Trucks positioned themselves strategically, materials were distributed, and teams prepared for simultaneous deployment. Time was critical, but so was stealth. The operation's success depended on completing the airstrip before German reconnaissance could detect any unusual movement. Every motion, every placement, every calculation contributed to a delicate balance between speed and secrecy. Challenges emerged immediately. Certain areas of the clearing were softer than predicted, threatening to sink mats under their weight. Unexpected obstacles, including small depressions and tree roots, required rapid adjustments. Engineers improvised, shifting trucks, manually stabilizing mats, and modifying deployment sequences on the fly. Despite fatigue and pressure, focus never wavered. Each engineer recognized that the smallest error could compromise the entire project. Yet the team continued, relying on training, preparation, and mutual trust to overcome obstacles with ingenuity and precision. Communication was critical. Teams used a combination of encrypted radio messages, hand signals, and pre-established codes to synchronize movements without revealing their position. Orders flowed instantly, adjustments were made in real time, and contingency plans were enacted when minor disruptions arose. The operation required both individual skill and collective cohesion. Each engineer understood the importance of timing, anticipating the movements of colleagues and machinery, while maintaining situational awareness. The airstrip's construction became a living demonstration of coordination and tactical foresight. By midday, progress exceeded expectations. Steel mats had been positioned, soil was compacted, and logistics were fully integrated. Engineers conducted test runs using lighter vehicles to verify surface stability and alignment. Adjustments were made efficiently with minimal delay. The precision of execution astonished supervising officers, who had observed from concealed positions. What had begun as a risky, audacious plan had transformed into a tangible, functioning asset. The clearing was no longer a simple patch of forest. It had become a critical instrument of strategic advantage. The impact on German forces was immediate, though delayed in perception. Commanders, confident in their surveillance capabilities, were blindsided by the sudden appearance of the airstrip. Their shock was compounded by the realization that American engineers had operated in plain sight, yet completely undetected. Pilots could now land closer to front lines, reducing response times and increasing operational flexibility. Enemy morale faltered as reports of the audacious feat spread, forcing generals to rethink defensive priorities and anticipate further extraordinary actions. The psychological dimension of the operation was as significant as its tactical outcomes. Engineers had demonstrated the power of innovation, preparation, and human ingenuity to achieve what conventional thinking deemed impossible. Their success validated a broader strategic principle. Decisive advantage could be gained not only through superior firepower but through creativity, adaptability, and meticulous execution. The airstrip symbolized a shift in the operational landscape, challenging assumptions and reshaping expectations. Engineers continued final adjustments as dawn approached. Every mat was aligned, connections verified, and the surface rigorously tested. The coordination of trucks, personnel, and materials reached near-perfect precision, reflecting months of preparation and countless hours of rehearsal. The airstrip, now operational, was ready to serve as a forward base for aircraft, extending reach and enhancing the effectiveness of subsequent operations. What had been an ambitious plan became a remarkable reality, achieved through discipline, technical expertise, and daring execution. By the time planes began their first landings, the engineers had already withdrawn from immediate observation points. Pilots were guided onto the newly constructed runway with precision, taking off and landing without incident. The operation had succeeded flawlessly, exceeding expectations and demonstrating the extraordinary capabilities of American ingenuity under pressure. The clearing, once overlooked and unremarkable, had become a decisive instrument of war, a testament to the skill, courage, and vision of the engineers who made it possible. The story of this overnight airstrip did not end with its completion. Its success influenced subsequent operations, serving as a model for rapid deployment, logistics coordination, and tactical innovation. Engineers' methods were replicated in other regions, providing the Allied forces with critical advantages in contested territory. Beyond the immediate operational benefits, the feat became a symbol of what could be achieved when human creativity and determination were combined with technical expertise and meticulous planning. This operation also highlighted the often overlooked contributions of support personnel in wartime. While soldiers and pilots received much of the recognition, engineers operated in relative obscurity, yet their work shaped the outcomes of entire campaigns. Every calculation, every adjustment, every decision to adapt to unforeseen challenges played a role in the success of the mission. The overnight airstrip became a reminder that ingenuity, preparation, and the courage to execute ambitious plans were as essential to victory as conventional military might. By the end of the day, the forest clearing had been transformed into a hub of strategic importance. Aircraft moved in and out efficiently, pilots reported the reliability of the surface, and intelligence confirmed that German forces were struggling to comprehend the feat for the engineers. The satisfaction lay not in accolades but in the knowledge that their ingenuity and effort had created a decisive advantage. They had turned a daring concept into reality, proving that even in the chaos of war, extraordinary outcomes were possible through discipline, creativity, and meticulous execution. As the first morning light filtered through the treetops, the airstrip stood as a testament to human ingenuity and the relentless discipline of those who had built it. Yet the engineers were far from finished. The initial success was only the first phase, sustaining the operational capacity of the airstrip, ensuring its longevity under combat conditions, and coordinating the arrival of planes demanded equal precision and adaptability. While the German generals scrambled to understand what had happened, the engineers began focusing on the next critical phase, transforming a functional runway into a fully integrated forward operating base capable of supporting continuous missions. Logistics became the immediate priority. Fuel supplies had to be strategically stored yet hidden from potential aerial reconnaissance. Ammunition and spare parts needed careful organization to ensure rapid access without obstructing the limited space of the airstrip. Temporary shelters were constructed to protect critical equipment from weather and provide operational spaces for pilots and support crews. Every placement was deliberate, every structure functional yet minimal in appearance to avoid detection. Engineers applied the same precision to this phase that they had applied to construction, knowing that efficiency and concealment would determine both operational success and survival. In parallel, teams began integrating communication networks. Field radios were established at multiple points along the airstrip, ensuring uninterrupted contact with command centers and pilots. Redundant lines of communication were implemented to account for potential equipment failure or enemy interference. Technicians calibrated each device, tested frequencies, and rehearsed rapid response procedures in case of unexpected disruptions. This network of communication was not merely a technical necessity. It was a safeguard, a lifeline that ensured every operation conducted from the airstrip could proceed with coordination and accuracy. Meanwhile, reconnaissance units conducted perimeter sweeps, identifying potential threats and ensuring that the airstrip remained undetected. Patrols were subtle yet thorough, moving through dense forest areas to verify that no observation points had been established by enemy forces. Any footprints, tire tracks, or unnatural patterns were corrected immediately. Concealment was an ongoing operation. The engineers understood that the airstrip's continued success depended on the German forces remaining unaware of its existence. This required constant vigilance, attention to detail, and a clear understanding of enemy behavior and surveillance methods. As aircraft began arriving, the engineers faced a new set of challenges. Pilots required guidance for landing and takeoff, particularly on a surface that, despite its solid construction, was still unconventional compared to permanent runways. Engineers positioned signaling equipment, markers, and lights in ways that maximized visibility while minimizing exposure. Each landing was carefully monitored, with teams ready to correct minor imperfections or respond to emergencies. The first flights were cautious, as pilots tested the runway's capacity, but soon, confidence grew as each landing confirmed the reliability of the engineers' work. The airstrip quickly became a hub of activity. Fuel trucks moved efficiently between storage areas and aircraft, while supply teams ensured that maintenance operations could be conducted without delay. Aircraft rotation schedules were established, maximizing the number of sorties while minimizing downtime. Engineers remained on alert, continuously inspecting the surface for wear, shifting mats, or any signs of potential failure. This level of operational oversight ensured that the airstrip could function at full capacity while maintaining safety for both pilots and crew. Adaptability proved crucial when unexpected challenges arose. Heavy rainfall threatened to soften sections of the runway, potentially causing mats to sink or shift. Engineers responded immediately, reinforcing affected areas with additional support structures and modifying drainage channels to redirect excess water. Trucks were redeployed to apply pressure, compacting the soil and stabilizing the mats. This dynamic problem-solving highlighted the engineers' ability to combine technical expertise with real-time strategic thinking, a combination that would prove decisive throughout the operation. At the same time, intelligence officers were monitoring enemy activity, providing updates that influenced operational decisions. Reports of German troop movements, reconnaissance flights, and patrol patterns were analyzed and integrated into the engineers' workflow. Adjustments were made to construction reinforcements, material placement, and perimeter concealment. Every decision was informed by both the immediate tactical situation and the broader strategic picture, ensuring that the airstrip could operate effectively while minimizing risk of discovery. As sorties increased, the scale of the operation expanded. Support structures were enhanced to accommodate larger aircraft, storage areas were reorganized to optimize space, and supply lines were refined to reduce response times. Engineers implemented modular solutions that allowed for rapid adjustments in layout, ensuring that the airstrip could adapt to changing operational demands. Flexibility became a hallmark of the operation. Every element was designed to function in isolation, yet contribute to a cohesive and efficient system. The psychological impact on pilots and support crews was profound. Confidence in the runway's reliability allowed pilots to focus on mission objectives rather than worrying about landing safety. Crew members gained assurance that logistical support was dependable, supplies were accessible, and communication networks were robust. The engineers' work had created more than a physical runway. They had established a sense of security and operational efficiency that enhanced overall mission effectiveness. Meanwhile, German forces continued to speculate, attempting to identify the source of this sudden tactical advantage. Generals convened emergency meetings, dispatching reconnaissance units to investigate. Yet every effort proved futile. The precision of the engineers' concealment, combined with the speed of execution, rendered enemy observation ineffective. The airstrip remained a ghostly, almost invisible presence within enemy territory, a hidden asset that would continue to influence operations for weeks to come. Throughout the expansion phase, engineers maintained strict discipline. Rotating teams ensured continuous oversight, while fatigue management strategies were implemented to sustain performance. Leaders conducted inspections, verified alignment and stability of the runway, and coordinated with pilots and mission planners. This attention to detail ensured that the airstrip remained fully operational, despite the intensity of activity and the inherent challenges of constructing and managing a forward operating base in contested territory. Innovation continued to drive solutions. When supply bottlenecks emerged, engineers devised temporary storage solutions using lightweight structures and natural concealment. Maintenance procedures were adapted to accommodate unusual materials and temporary construction methods. Improvisation, when necessary, was guided by a deep understanding of physics, engineering principles, and tactical needs. Each decision was calculated, balancing efficiency, safety, and stealth. The success of the airstrip had strategic ramifications beyond immediate operations. Aircraft now had closer access to forward positions, allowing faster response times, improved reconnaissance, and enhanced flexibility in executing missions. Enemy forces were forced to divert resources, anticipate further surprises, and contend with the uncertainty introduced by this audacious feat. The engineers' work had reshaped the operational landscape, proving that creativity, coordination, and technical skill could rival even the most heavily fortified positions. As operations continued, engineers began documenting methods and procedures, ensuring that the airstrip could serve as a model for future missions. Photographs, diagrams, and notes captured every innovation, every adjustment, and every contingency that had been employed. This record would later inform subsequent operations, allowing similar feats of rapid construction and operational readiness to be replicated in other theaters. The overnight airstrip became more than a tactical advantage. It became a blueprint for engineering excellence under pressure. By the end of the second day, the clearing had been fully transformed into a bustling operational hub. Aircraft moved efficiently, supply lines were fully integrated, and personnel coordinated seamlessly across multiple functions. The engineers' foresight, planning, and adaptability had converted a bold concept into a sustained operational reality. Their success underscored the power of preparation, ingenuity, and teamwork in shaping the course of war. The story of this airstrip would be remembered not for its speed alone but for the skill, dedication, and innovative thinking that made it possible. The engineers had demonstrated that victory could be influenced as much by creative problem-solving as by conventional weaponry. Each mat laid, each truck deployed, each adjustment made in response to unforeseen challenges represented a contribution to a larger strategic triumph. In doing so, they redefined what was possible in wartime logistics and engineering, leaving a legacy that extended far beyond the forest clearing where their work had begun. With the airstrip fully operational, a new set of challenges emerged, shifting the engineers' focus from construction to sustained operational support. Aircraft were landing and taking off continuously, demanding precision maintenance, rapid refueling, and constant monitoring of the runway's structural integrity. Each landing carried the weight of strategy. Every takeoff propelled missions that could shift the balance of power. Engineers became both builders and guardians, ensuring that every plane's interaction with the improvised surface proceeded flawlessly, even as conditions evolved under the pressure of ongoing wartime operations. Maintenance became a continuous endeavor. The constant movement of aircraft caused wear on mats and soil, creating subtle shifts that could compromise landing safety. Engineers implemented rotating inspection teams, moving across the runway systematically to detect and correct misalignments, sinking mats, or uneven surfaces. Tools were distributed along the perimeter, ready for immediate deployment. Each engineer carried the knowledge that a single oversight could jeopardize a mission or, worse, endanger a pilot's life. The stakes created a heightened sense of vigilance, fostering an environment where precision and responsiveness became second nature. Parallel to structural maintenance, logistical coordination intensified. Fuel reserves had to be replenished without interruption, spare parts allocated efficiently, and supplies organized to maximize access while maintaining concealment. Engineers devised innovative storage solutions, using natural terrain and temporary structures to protect resources from both environmental factors and enemy reconnaissance. Every logistical decision was informed by anticipation. How many sorties would be flown in the next 12 hours? How quickly could aircraft be turned around? And what contingencies were needed if enemy forces discovered the airstrip? Operational readiness depended on this continuous cycle of planning, execution, and adaptation. Communication networks evolved to handle increased operational complexity. Field radios connected pilots, engineers, and command centers, providing real-time updates on airstrip conditions, weather changes, and enemy movements. Signals were encrypted and monitored constantly, ensuring that crucial information was transmitted securely and without delay. Engineers coordinated adjustments to runway surfaces based on immediate feedback, demonstrating an agile approach that combined technical expertise with situational awareness. Every message, every signal played a role in sustaining the effectiveness of the airstrip, reinforcing the interdependence of technology, planning, and human execution. Environmental factors introduced additional challenges. Heavy rainfall threatened sections of the runway, softening soil beneath mats and creating the risk of uneven surfaces. Engineers responded with rapid reinforcement techniques, deploying additional mats, compacting soil, and adjusting drainage channels to redirect water flow. Wind, temperature fluctuations, and forest debris required constant monitoring and adaptation. Each adjustment was executed with the awareness that operational safety depended not only on skill but on the ability to anticipate environmental impacts. This dynamic approach ensured that the airstrip could support continuous operations under unpredictable conditions. Aircraft operations increased in intensity, stretching both human and material resources. Pilots relied on the airstrip's reliability for crucial missions, reconnaissance flights, supply drops, and rapid troop deployments. Engineers guided landings with carefully positioned markers and signaling devices, ensuring that every approach remained safe. Coordination between landing and departing planes was orchestrated to minimize conflict and maintain efficiency. Each successful landing reinforced confidence in the engineer's work, validating months of planning and weeks of intense execution. German forces, still grappling with the sudden emergence of the airstrip, attempted to mount countermeasures. Reconnaissance flights and patrols were dispatched, but they proved largely ineffective. The engineers had anticipated potential observation routes, employed camouflage, and structured the airstrip layout to minimize visibility. Every measure reflected a deep understanding of enemy behavior and surveillance patterns. By remaining several steps ahead, the engineers ensured that operational continuity remained uninterrupted, turning tactical ingenuity into a form of invisible dominance. Beyond immediate operational concerns, engineers began optimizing the airstrip for future missions. Modular designs allowed for quick expansion, Adjustments in layout accommodated heavier aircraft, and storage areas were refined to support prolonged operations. Every modification was tested and implemented with precision, ensuring that the airstrip could evolve alongside the demands of the broader campaign. Flexibility became a defining characteristic, enabling rapid adaptation to changing mission requirements and environmental conditions. The psychological dimension of the operation remained profound. Pilots and crew members gained confidence in the safety and reliability of the airstrip, enhancing morale and operational efficiency. Engineers, though operating behind the scenes, became the linchpin of mission success. Their meticulous attention to detail, problem-solving skills, and unwavering focus translated into tangible operational advantages. The airstrip had become more than a landing surface. It was a symbol of American ingenuity, demonstrating that preparation and coordination could achieve what appeared impossible in enemy territory. Strategic planning extended beyond the airstrip itself. Engineers coordinated with intelligence officers to anticipate enemy responses and adjust operational protocols accordingly. Potential threats, such as surprise reconnaissance flights or sabotage attempts, were identified and defensive measures implemented. Observation posts were strategically positioned, patrol schedules adjusted, and contingency plans rehearsed. The interplay between operational functionality and security measures reflected a holistic approach, where engineering excellence was inseparable from tactical foresight. Innovation continued to drive problem-solving. When supply chains were disrupted, engineers devised alternative methods to transport fuel, materials, and equipment efficiently. Makeshift bridges, temporary roadways, and pulley systems allowed resources to flow seamlessly across challenging terrain. Improvisation, guided by rigorous planning, ensured that operational momentum was never compromised. Every obstacle encountered became an opportunity to refine processes, demonstrating the adaptability and resilience of the engineering teams. As operations stabilized, the airstrip became a hub of intelligence gathering. Observers recorded enemy movements, pilots provided feedback on strategic needs, and engineers adapted infrastructure to support reconnaissance missions. The flow of information informed decision-making at every level, creating a feedback loop that strengthened both tactical and strategic outcomes. The airstrip had evolved from a simple landing site into a dynamic operational platform, where engineering, intelligence, and military strategy converged. Coordination between different teams became increasingly sophisticated. Engineers, pilots, supply personnel, and intelligence officers worked in unison, anticipating each other's needs and responding to challenges proactively. The airstrip operated as a cohesive system, where every individual contributed to collective efficiency. This integration of human effort, technical skill, and strategic vision ensured that operations proceeded smoothly, even under high pressure and with limited external support. The success of the airstrip began to influence broader operational strategies. Commanders recognized that rapid deployment and adaptability provided a significant tactical advantage. Missions could be launched closer to enemy positions, response times were reduced, and strategic flexibility increased. The engineers' achievement reshaped expectations about the speed and effectiveness of infrastructure deployment in wartime. Their work demonstrated that innovation and disciplined execution could rival the impact of conventional military superiority. By the end of the third day, the airstrip had proven itself as a reliable, adaptable, and strategically significant asset. Aircraft operations proceeded without incident, logistical flows remained uninterrupted, and engineers continued to refine and maintain the infrastructure. The combination of meticulous planning, innovative problem-solving, and seamless coordination had transformed a temporary installation into a sustained operational hub. Every mat laid, every adjustment made, and every decision taken contributed to the broader success of the Allied campaign. The legacy of this airstrip extended beyond its immediate tactical impact. It became a blueprint for future operations, demonstrating that ambitious objectives could be achieved with discipline, ingenuity, and collaboration. Engineers' methods were studied, replicated, and adapted to other theaters, proving the enduring value of their work. Beyond the tactical advantages, the operation showcased the transformative potential of human creativity, foresight, and courage in shaping the outcomes of war. The story of the airstrip was not only one of engineering success but also of human determination. Engineers faced extreme conditions, high stakes, and the constant pressure of operating behind enemy lines. Their achievements were a testament to resilience, skill, and the capacity to turn audacious plans into reality. The airstrip exemplified how preparation, coordination, and adaptability could create decisive advantages, leaving an indelible mark on the course of military operations and the history of innovation in warfare. By the fourth day, the airstrip had become a central artery of Allied operations, a physical manifestation of strategic ingenuity and operational precision. Its existence challenged German assumptions about the reach and capabilities of American forces. Engineers, having already demonstrated remarkable skill in construction and maintenance, now faced the challenge of scaling operations to support increasingly complex missions. The pressure was intense. Every decision carried consequences. Every oversight could compromise the airstrip's functionality or expose it to enemy discovery. Yet through careful coordination, disciplined execution, and adaptive problem-solving, the engineers continued to expand and refine their work, turning a temporary runway into a lasting strategic asset. The scale of operations had grown dramatically. Aircraft of different sizes, from light reconnaissance planes to heavy bombers, rotated in and out of the airstrip, each requiring specialized attention. Landing protocols were adjusted for varying weights and speeds, while engineers monitored every square foot of the runway for signs of wear or instability. Maintenance crews worked around the clock, guided by schedules meticulously crafted to ensure continuous operational readiness. Every mat placement, soil reinforcement, and alignment adjustment was executed with exacting precision, reflecting the engineers' deep understanding of both physics and military requirements. Logistics remained a constant challenge. Supplies of fuel, ammunition, and spare parts had to be replenished frequently, often traversing difficult terrain or being transported under conditions that demanded both stealth and speed. Engineers developed innovative methods to streamline these operations. Temporary storage depots were camouflaged within the forest, accessible via concealed pathways. Makeshift cranes and pulley systems facilitated the rapid movement of heavy equipment, while supply teams were trained to anticipate the next mission's needs, ensuring that no delay compromised operational capacity. This orchestration of resources transformed the airstrip into a well-oiled machine capable of sustaining intensive sorties. The engineers' adaptability was tested further by unpredictable weather conditions. Sudden storms threatened to flood sections of the runway, while high winds scattered debris and weakened soil stability. In response, drainage channels were reinforced, mats were secured more firmly, and temporary barriers were erected to protect critical infrastructure. Every adjustment was carefully documented, providing lessons for future operations and ensuring that lessons learned could be applied immediately to maintain uninterrupted functionality. This proactive approach exemplified the engineer's ability to anticipate challenges and respond with effective solutions under extreme pressure. As aircraft operations intensified, communication systems became increasingly crucial. Engineers coordinated with pilots, command centers, and support teams through a network of encrypted radios, field signals, and pre-established codes. Real-time updates on runway conditions, weather changes, and enemy movements allowed for rapid adjustments, ensuring that operations continued without disruption. This integration of technology and human judgment created a dynamic environment in which information flowed seamlessly, reinforcing both operational efficiency and strategic advantage. The psychological dimension of the airstrip's success became increasingly evident. Pilots gained confidence in the runway's reliability, allowing them to focus entirely on mission objectives rather than landing risks. Crew members trusted that logistical support would be available exactly when needed, fostering a sense of stability amid the chaos of war. Engineers, despite operating behind the scenes, emerged as silent leaders whose skill and precision directly influenced mission outcomes. The airstrip had become a symbol not only of technical ingenuity but also of the transformative power of coordination and trust in high-stakes environments. Enemy forces, meanwhile, remained baffled. German reconnaissance efforts, initially aggressive, proved largely ineffective against the engineers' strategies of concealment and adaptation. Observation points were avoided, patrols were misled, and the airstrip continued to operate undetected. The engineers' understanding of enemy psychology and reconnaissance techniques allowed them to anticipate likely detection methods and implement countermeasures proactively. Every precaution, from camouflaging fuel depots to designing layout patterns that minimized visibility, reinforced the airstrip's operational security and effectiveness. Innovation continued to drive improvements. Modular structures allowed for rapid expansion, enabling the runway to accommodate a broader range of aircraft and larger mission volumes. Supply chains were refined, with alternative routes and contingency plans established to mitigate potential disruptions. Engineers experimented with new materials and deployment methods, testing combinations of mats, soil compaction techniques, and support structures to maximize durability under repeated use. This iterative approach ensured that the airstrip remained resilient and adaptable, capable of supporting complex and sustained military operations. The airstrip's role expanded beyond purely logistical functions. Reconnaissance flights launched from the site provided critical intelligence, enabling strategic decisions and shaping broader operational planning. Engineers adapted infrastructure to support these missions, ensuring that observation equipment, communication systems, and supply lines were optimized for maximum effectiveness. The airstrip had evolved into a multifaceted operational hub, where engineering, intelligence, and strategic planning converged seamlessly to create tangible advantages on the battlefield. Coordination across teams became increasingly sophisticated. Engineers, pilots, supply personnel, and intelligence officers worked in close synchronization, anticipating each other's needs and adjusting operations in real time. Training exercises ensured that personnel could respond to emergencies, environmental challenges, or unexpected enemy activity without compromising operational flow. The interdependence of these teams transformed the airstrip from a simple landing site into a complex system capable of sustaining high-intensity operations under challenging conditions. The strategic implications of the airstrip's existence became increasingly apparent. Aircraft could now operate closer to enemy positions, reducing response times and enabling more precise strikes. Commanders recognized that this newly established forward base offered unparalleled flexibility and tactical advantage, forcing enemy forces to divert attention and resources to account for the unexpected presence. The engineers' achievement reshaped assumptions about what could be accomplished in contested territory, demonstrating that innovation, discipline, and foresight could rival traditional measures of military strength. Even as operations continued, engineers documented their methods meticulously. Every innovation, adjustment, and contingency plan was recorded, creating a comprehensive manual for future rapid deployment operations. This documentation ensured that lessons learned could be applied elsewhere, allowing other engineering teams to replicate the success of the overnight airstrip under similar conditions. The operation had evolved from a localized tactical feat into a broader strategic model, influencing the planning and execution of subsequent Allied operations across multiple theaters. The physical and mental endurance of the engineers remained remarkable. Long hours, constant vigilance, and high-pressure decision-making defined their daily routines. Each individual was aware that their work was critical not only to immediate missions but also to the broader success of the campaign. This sense of responsibility, combined with a deep understanding of engineering principles and operational strategy, fostered a culture of excellence, resilience, and unwavering focus. The airstrip became a testament to the power of human skill and determination in overcoming extreme challenges. By the fourth day, the cumulative impact of the engineers' efforts was evident. Aircraft operations proceeded smoothly, logistical systems functioned efficiently, and the runway remained structurally sound despite continuous use. Pilots and support personnel operated with confidence, while enemy forces struggled to comprehend the sudden emergence and sustained effectiveness of the forward base. The engineers' work had transformed the airstrip into a decisive tool of operational superiority, demonstrating that meticulous planning, adaptability, and innovation could achieve extraordinary results in wartime environments. The story of the overnight airstrip, now firmly established, reflected broader truths about human ingenuity in conflict. Engineers had demonstrated that audacious objectives could be realized through careful preparation, disciplined execution, and the capacity to adapt to unforeseen challenges. Every aspect of the operation, from soil compaction to modular construction, from logistics coordination to operational security, highlighted the transformative potential of strategic engineering under pressure. Their work stood as a reminder that in warfare, innovation and resourcefulness could create advantages that traditional tactics alone could not achieve. The airstrip also underscored the importance of collaboration. Engineers did not work in isolation. Their success depended on seamless coordination with pilots, intelligence officers, and support crews. Each individual's expertise contributed to a cohesive system capable of responding dynamically to evolving operational demands. The resulting synergy amplified the effectiveness of the airstrip, allowing it to function not merely as a landing site, but as a strategic instrument capable of shaping the broader theater of operations. By the close of the fourth day, the airstrip had secured its place as a symbol of American ingenuity, operational excellence, and strategic foresight. Its existence challenged assumptions about what could be achieved under pressure, demonstrating that meticulous planning, relentless execution, and adaptive problem-solving could yield extraordinary results. Engineers had turned a bold, risky vision into a tangible reality, creating a forward operating base that would influence the course of missions, disrupt enemy expectations, and redefine possibilities in wartime engineering. As operations entered their final phase, the airstrip had transformed from a daring concept into a cornerstone of strategic advantage. Its impact extended beyond the immediate tactical benefits, shaping broader campaign dynamics and forcing German forces to reevaluate their understanding of American capabilities. The engineers' achievement was not simply in constructing a functional runway overnight. It was in establishing a self-sustaining, resilient, and adaptable forward base that operated efficiently under constant pressure and remained virtually invisible to enemy forces. Aircraft continued to arrive in increasing numbers, their missions spanning reconnaissance, supply drops, and direct engagement with enemy positions. Engineers worked tirelessly, ensuring that runway surfaces remained intact, supplies were readily available, and maintenance operations were performed without delay. Each sortie relied on the meticulous planning and rapid responsiveness that had become the hallmark of the operation. Pilots trusted the runway implicitly, knowing that every landing and takeoff had been accounted for with precision. The engineers had created not only a physical platform but a foundation of confidence and operational assurance. The operational tempo accelerated. Multiple flights were coordinated simultaneously, with engineers directing takeoffs and landings in rapid succession. Signals, markers, and communication devices were carefully calibrated to manage the flow of aircraft safely. Every adjustment was a calculated decision. The positioning of a mat, the alignment of a signal, the timing of a departure, all played a role in maintaining operational efficiency while minimizing the risk of error. The success of these coordinated efforts highlighted the engineers' ability to operate under high-stress conditions while maintaining exacting standards. Logistical demands escalated as well. Fuel, ammunition, and spare parts needed constant replenishment to match the pace of aircraft operations. Engineers and support teams devised innovative solutions to manage this increased workload, deploying modular storage units, concealed pathways, and rapid transfer systems. Each improvement reflected a deep understanding of both material handling and operational security. Even under extreme time constraints, the engineers ensured that resources were available precisely when and where they were needed, sustaining uninterrupted operational capacity. Environmental challenges persisted. Heavy rains threatened sections of the runway, while wind and debris posed constant hazards. Engineers responded with adaptive reinforcement strategies, deploying additional support mats, modifying drainage systems, and clearing obstacles before they could affect operations. Every measure was preemptive and precise, reflecting both technical expertise and situational awareness. Their ability to anticipate and mitigate environmental impacts ensured that the airstrip remained fully functional, even as conditions fluctuated. Enemy reconnaissance intensified as German generals sought to understand the sudden emergence of the airstrip. Patrols were dispatched, aircraft flew overhead, and intelligence reports were scrutinized. Yet, despite these efforts, the engineers' careful planning and concealment strategies remained effective. Camouflage, strategic placement of supplies, and an understanding of likely enemy observation points ensured that the airstrip continued to operate without detection. Each day reinforced the advantage gained by foresight, preparation, and attention to detail. Innovation remained a constant theme. Engineers continuously refined construction techniques, tested new methods for securing mats, and developed rapid response protocols for potential emergencies. Temporary shelters were reinforced, communication networks upgraded, and operational procedures adjusted to accommodate evolving mission requirements. This iterative approach allowed the airstrip to adapt dynamically to both operational and environmental demands, ensuring long-term effectiveness and resilience. The psychological effect on personnel was profound. Pilots gained confidence in their ability to execute missions efficiently and safely. Support crews trusted that logistical and maintenance needs would be met without delay. Engineers, while operating behind the scenes, were recognized as the linchpins of operational success. The airstrip had become a symbol of ingenuity, resilience, and precision, demonstrating that human skill and strategic planning could achieve extraordinary results even in hostile territory. Strategic coordination expanded beyond the airstrip itself. Engineers worked closely with intelligence officers, pilots, and commanders to anticipate enemy movements and optimize operational planning. Reconnaissance data informed adjustments to runway operations, logistical placement, and defensive measures. Each flight and mission benefited from this integration, reinforcing the interdependence of engineering excellence, tactical planning, and strategic foresight. The airstrip had evolved into a multifaceted operational hub, where decisions were informed by both technical capability and real-time intelligence. The cumulative impact of the airstrip became increasingly clear. Aircraft now had unprecedented access to forward positions, enabling rapid response, improved reconnaissance, and strategic flexibility. German forces, forced to contend with an unexpected and effective forward base, were compelled to divert resources and reassess their strategies. The engineers' work had reshaped operational expectations, proving that speed, innovation, and meticulous planning could create advantages that rivaled traditional measures of military strength. Innovation extended to personnel management and operational sustainability. Rotating shifts, rest schedules, and efficiency protocols ensured that engineers and support staff maintained peak performance. Contingency plans were rehearsed continuously, preparing teams to respond to potential emergencies, equipment failures, or sudden environmental changes. This structured approach ensured that operations remained smooth, even under intense pressure, and reinforced the airstrip's reliability as a central hub of Allied activity. As sorties increased, so did the demand for precision. Each landing, takeoff, and maintenance procedure was scrutinized to minimize risk. Engineers implemented real-time monitoring systems, performed continuous inspections, and adjusted operational protocols based on immediate feedback. The integration of observation, adaptation, and execution ensured that the airstrip could sustain high-intensity operations without compromise. Every action reinforced the broader strategic objective, maintaining operational superiority while remaining concealed from enemy observation. By the fifth day, the airstrip had become a model of wartime engineering excellence. Its design, execution, and operational management demonstrated that audacious objectives could be realized through preparation, innovation, and disciplined teamwork. Pilots and crew operated with unprecedented confidence, while German forces continued to struggle with the implications of this hidden, highly effective installation. The engineers' work had shifted the balance of tactical possibilities, proving that rapid deployment, adaptability, and strategic foresight could redefine the theater of operations. The airstrip's operational success had long-term implications. Engineers meticulously documented every method, adjustment, and contingency plan, creating a blueprint for future rapid deployment initiatives. This record ensured that the techniques developed could be applied in other theaters, allowing similar feats of engineering to influence the course of additional operations. Beyond its immediate tactical value, the airstrip became a source of institutional knowledge, demonstrating the power of innovation, collaboration, and disciplined execution in shaping military outcomes. Human endurance, ingenuity, and collaboration were at the heart of the operation. Engineers, despite facing extreme conditions and continuous high-pressure demands, maintained focus, precision, and adaptability. Each individual understood that their work had ramifications far beyond the immediate physical environment, influencing mission success, pilot safety, and broader strategic objectives. The airstrip was more than a construction project. It was a living testament to what disciplined, creative, and coordinated human effort could achieve under extraordinary circumstances. By the close of operations, the airstrip had secured its place in wartime history. It had provided unmatched operational flexibility, sustained intense mission volumes, and demonstrated the transformative power of innovation in the face of logistical, environmental, and tactical challenges. German forces, unable to comprehend or counter the rapid emergence of such a capable forward base, were forced to contend with a new reality on the battlefield. The engineers' achievement had redefined the parameters of possibility, proving that audacity, skill, and meticulous planning could create decisive advantages. The legacy of the overnight airstrip extended beyond the immediate success of the mission. It exemplified how strategic vision, technical expertise, and human perseverance could converge to achieve extraordinary results. Engineers had transformed a bold plan into a sustained operational hub that not only served immediate tactical needs, but also influenced broader strategic outcomes. The airstrip became a symbol of ingenuity, discipline, and resilience, inspiring future generations of military engineers and strategic planners. In the end, the story of this remarkable engineering feat highlighted a fundamental truth. Innovation, precision, and coordination could rival brute force in determining the course of conflict. The overnight construction of a fully operational airstrip, executed under the pressure of enemy territory and the uncertainty of wartime conditions, demonstrated the extraordinary potential of human skill and collaboration. Pilots, engineers, and support teams had collectively rewritten the rules of what could be achieved in combat operations, leaving a lasting impact on both history and the practice of military engineering. The airstrip's success, a combination of speed, ingenuity, and strategic insight, stood as a testament to the human capacity to overcome challenges under extreme conditions. It demonstrated that audacious ideas, when paired with meticulous execution and adaptive problem-solving, could produce results that transformed the operational landscape. Every mat laid, every adjustment made, and every mission executed from this hidden runway contributed to a narrative of courage, intelligence, and innovation that would endure far beyond the forest clearing where it had begun. As the story of the overnight airstrip spread among Allied forces, it became emblematic of a broader principle: that in war, creativity and disciplined execution could alter the balance of power, creating advantages that were invisible until realized on the battlefield. The engineers had achieved something remarkable, not merely building a runway, but reshaping the operational possibilities of an entire campaign, demonstrating that ingenuity, coordination, and relentless commitment could produce extraordinary results even in the most challenging and uncertain circumstances.